Good morning. Welcome to our debate today on how much intelligence you can pack into a pick-and-place machine. Pick-and-place machines are pretty much at the heart of every manufacturing line, and machine uptime is critical. So we've got a panel here to discuss machine uptime and how it integrates with the smart factory automation. Joined by a distinguished panel. To my extreme right, we have Richard Verjeissen from Yamaha. Welcome, Richard. Then we have Shawn Robinson from Panasonic. And to my immediate right, we have Jeff Timms from ASM Assembly Systems.
Thank you, Trevor.
Okay, nice to see you all. Thank you for joining us.
Thank you.
So we're going to go straight in, and I think my first question is going to be, IPC states that the amount of factory downtime or machine downtime is somewhere in the region of 37%. Notwithstanding changeover times, what can manufacturers do to reduce that downtime? Richard, do you want to take that first?
Yeah. Mainly the whole preparation of the software. The software preparation, offline, preparing all the programs, especially for MPI. There's a lot of things that people still want to do on the machine, but these days the software is that powerful that you can do 100% offline visual check the whole program. So during your production process, you don't have any downtime that much anymore when you're introducing a new product.
Right.
And we keep up with this preparation software so that customers can just entering any new product into the production environment anytime, any type of product, because all the program preparation has been done already offline.
Right. Okay. So better software preparation with the system to reduce the amount of downtime. I mean, one of the things, for example, that could be done as well is maintenance scheduling. Better maintenance scheduling, because quite often you'll get an engineer comes across and says, "Well, I need to get onto that machine." Well, they need to wait till the time it to in between the changeovers, basically. Shawn, what would you suggest for this?
I think this is going to be a nice transition, because I also think that once you have the product set up, right, being able to locate material, replenishment, all kinds of different opportunities for there to be downtime, whether it be an interruption at the machine, or whether it be locating parts to be able to keep the machine up and running. A couple of things that I foresee in the near future is the machine being able to analyze its own performance and be able to take corrective action without any human intervention.
So they call it AI, basically.
Yeah.
And
beyond that, there are some times where events happen where you need access to the user interface to overcome a very simple interruption. If you could make that event available to somebody remotely and be able to recover from it by having a screen come up and have somebody, an engineer at their desk, be able to overcome that situation. You don't actually have to have a human go to the line. That's another level of efficiency that can be gained. And lastly, I think what you'll also see in the near future is there's going to be circumstances where you have to have a human involved. And any way that you can quickly direct any available resource to go and recover from a tape jam or whatever the event might be, I think is another level of capability that is very close to being available on the market for people to take advantage of, to maintain higher utilizations once you have the product set up and running. That's another way we can improve utilization.
Yeah. One of the things that was actually discussed in our last debate was the business of capturing data and basically turning it into actionable data. Sure. That's a bottleneck. Right. So being able to do that quicker and faster and educate, have skilled knowledge workers to be able to do that is an important thing. Jeff, what's your view?
So I think it kind of falls into a couple of different categories, and certainly part of it is program preparation. But as the processes get more and more complicated, that the cyber-human interface has to become simpler, right? And so with more and more complexity in the subsystems, there's another layer of automation that has to take place to keep it simple. If you look at just smartphones as an example, 15 years ago, the phones we were carrying around were rather complicated.
Right.
Today, they don't even come with a manual.
That's right.
Right.
Yeah,
It's all app based.
Icon driven.
That you point and click, and away you go. So if you think about our assembly systems, part of it falls into maintenance, but really, if you analyze the downtime on a factory floor, if you're playing with one of the top tier providers of equipment today, downtime is machine breaking, and downtime associated with that is not the issue on the floor. The machines just run, right? So that leads you into replenishment strategies, it leads you into operator strategies, it leads you into preventive maintenance strategies, and how do you control and manage all of that stuff, right? So one of the objectives in any of the 4.0 initiatives is to minimize the amount of manual labor required in anything that we're doing. So if you think about what used to be 2 or 3 operators on the line, and then a bank of maintenance technicians, that's all being replaced with a small central group of virtual repair people and virtual control people for the factory floor. And I think this is becoming more and more a reality. And when you combine that with remote support over the wire, remote support over the airwaves, it starts to come together very quickly, and you've gone from a factory that had 16 people running 4 lines to a factory that's got 3 people running 4 lines.
Right.
And all of a sudden you have real savings, and you're right. You mentioned about a 37% downtime. I think that's generous in most cases.
Right.
But it has nothing to do with whether the machines are running.
Right.
It's all the workflows around it.
The workflows around it, exactly.
That's right.
Exactly. An interesting one I saw just actually in the booth next to us here at BTU. They've just launched this week a dual lane oven, but that is independent lanes and independent zones, so you can literally do 2 different jobs running in parallel.
Eliminate the settling and the zone normalization times.
Right. But I mean, the beauty of it is that you could also use it to keep permanent uptime.
Yes.
You could be setting up the next job on one line while the other one's running.
That's right.
So again, another way to try and keep using dual lane, keeping the system going.
Yeah. So it really gets into changeover strategies.
Yeah.
It gets into automatic replenishment strategies. It gets into logistics and control strategies, and of course the maintenance strategies.
Right. Okay. Now, I think it was last November, I visited the ACES Technology Days over in Germany, and they had a robot loading feeder banks onto a Fuji machine. No human intervention.
Right.
Do you think that's going to be possible in the future, that we're going to have no human intervention in terms of actually loading?
No question. It will happen. It's not a question of if, it's when.
It's when. Okay.
So absolutely.
So you all have strategies in place to sort of address that going forward?
Absolutely.
Yeah.
Absolutely. And in fact, if you think about the factory floor, the way we historically look at the line, you have multiple machines, one feeding the other, feeding the other, feeding the other. If you think about the world of virtual planning, you almost have a factory floor. We're getting to the point where you almost have a factory floor where you have islands of capacity. Any machine can run any part, and you may go into this machine and then go across the aisle to that machine, and then go back across the aisle to another machine because you needed those capabilities.
You need these different processes and capabilities.
Exactly.
Yeah, I've noticed that.
All hands off.
Right, I noticed that as well. Everything seems to be splitting it into islands of capability, which is interesting. Okay. By the same token, are tapeless or bulk feeders likely to become a standard going forward? What do you think about that, Richard?
Yeah, we introducing beside our Sigma platform the super loading feeder, also the auto loading feeder. Just tapes putting into the feeder, and it's auto loading. The top tape will be removed automatically. So it's becoming more simple and less error.
Less problematic.
Less problematic.
Yeah.
So we'll have less downtime on feeder issues, loading issues, splicing issues. I think this is, everybody's asking, and this will take off this year rapidly. Yeah.
What's the Panasonic approach to that?
We also have auto-loading feeder technology. I think we've all gone through the cycles of bulk feeding in place machines being popular then unpopular. I think bulk feeding passives, especially in the case of capacitors, is a solution that will result in positive yields and no risk. Depending on which customer you talk to and the different studies that they've done when it comes to resistors, because the resistance tends to be on the top of the component, depending on thermal conditions that the product could be exposed to, that can be risky. So the type of bulk feeder and bulk feeding you could do, you can manipulate it mechanically. I think for small NPI environments where you want to take a strip of parts and be able to put them into a feeder for that type of environment, I think in high speed, capacitors, absolutely. Resistors, I'm not so sure. And obviously, if it's a leaded or bump device, there's always some risk of damage of the critical feature that's going to engage with the circuit board. So I think that to some extent, yes, especially in the NPI arena, high volume production for certain components, I think bulk feeding has a place for sure.
Yeah, I would agree with most of all of that. But if you think about historical methods of bulk feeding, it is problematic to say the least. But one thing that's changed in the last few years are communication speeds between processors and the ability to, for example, in the case of our approach at ASM, we actually dump the parts onto a glass plate. We have a camera that looks at them. It can tell you the orientation. It can tell you whether they're right side up, upside down, on edge, or whatever. And at full speed, whether it's capacitors or resistors or diodes or whatever, the communication between that processor and the machine is fast enough that we can pick these up at full speed without slowing down the cycle time at all. So it really works out well.
Okay.
And and without actually physically touching them, you don't introduce the damage.
Right. And you're doing that with capacitors.
Capacitors and resistors.
And resistors.
Yes, absolutely.
Okay.
When you can put 1.5 million components in a chamber,
So there's some benefit.
all of a sudden you don't have to load a bunch of tapes.
Right. Okay. How do your systems cope with small changes in component sizing? I mean, for example, if you've got one batch of components, reels comes in from one supplier, the same value of component come in, but they're in from a different supplier, and there's just a marginal difference in physical size. Do your systems autocorrect, or do you have? Are you using vision for that to?
Yeah, we do it automatically. So it's an automatic tuning for the visions file. The operator don't need to do anything, and it's all the software is handling this automatically.
Okay.
We also have the ability to auto-tune. The machine, again, will monitor its own performance. It knows when a splice event occurred or some type of event that will increase the probability that the need for the machine to go into a autocorrect condition is detected, and that could even be beyond just the part complexity, because the packaging can slightly change as well. The machine can automatically compensate based on the fact that it knows a transition from one carrier to the next. So it can sometimes be part related, sometimes it's packaging related, and so on. And so the technology is there today to be able to compensate for that.
Yeah, and the key is it has to be totally automatic, right? If the bottom line, you don't want any operator assists.
Right.
You want to be able to load the components. It may be a different package form than the other, but electrically the same value. You have to be able to automatically correct. If there's, in most cases, any kind of orientation problems are automatically detected and automatically corrected on the fly. But it comes back to the whole concept of keep the line always running.
Yep. Now, just looking at some of the inspection systems we have out there, like Ko-Young, for example, they automatically detect the size, and of course it's very measurement driven. And with the future factory automation debate, you need data. You need to be able to give you accuracy.
Yes.
Really, at the end of the day.
Absolutely.
Okay. So let's move on. What improvements do we need to see in sensor technologies to improve detection and placement accuracy. Who wants to pick that one up first?
I'll take a stab at it. If you think about where the equipment is today compared to even 5 years ago, it wasn't so much about whether or not sensor technology exists. It's about what cost was the sensor technology. Right. So as we continue to march forward with the advancement of technology, better and better sensors are being made available at much more reasonable prices. So that allows us to implement so much scanning technology, visioning technology, measurement technology, volumetric measurement technology, areas of measurement technology, 3D on the fly 3D, planarity testing, all of these types of things to eliminate potential errors later on in the process.
Right.
And I think the price of most sensing technologies is dropping so fast that it's becoming much more realistic.
Absolutely. I also think leveraging any sensor technology in the system also is an advantage. There's so much power, whether it be, something inside the Panasonic machine, or a partner or some other sensor technology from an AOI or an SPI, ICT, whatever the case might be, allows us to be able to look at it from a more holistic perspective. I agree with Jeff completely that the technology that we can offer, in the past you had a separate coplanarity sensor, you had a separate thickness sensor, and you had a separate 2D sensor. All can be now consolidated into one technology, but the fact is it's almost a living, breathing entity, the line is, and the more that we can kind of leverage each other, I think allows us to ultimately be able to provide better quality and performance and efficiency and so forth. So it's a whole new world, really.
Yeah,
it really is.
It's changing quite fast as well. As miniaturization increases and we need higher accuracy, does vibration play a more significant role? I mean, do you need to have more, look at your frame constructions, the weight of your frames, etc., so that you're going to get more stability for the placement process?
No question.
Yeah, that's where it all starts, with a frame that you're building, and the technologies of analyzing a frame, how it's vibrating during production in a CAD data program. It's so powerful these days, so you can optimize your whole base system offline already before you even start to manufacturing those bases. And with the technology of today, you can build even a lightweight construction and still keeping the vibration-free, stable base that will handle all these circumstances. Goes faster, it needs to place more components per hour, so speed, processing, everything is increasing. And with the technology of today, it's easy to pack it in a new system.
Right. But when you look at, say, for example, the laser industry, they have to build these laser systems on granite for safety, apart from anything else, and so they can't afford that thing to go out of alignment and damage somebody. So, are we going to have to go down to that level at some point?
It depends on what we're looking at. I mean, one of the things we were talking just a few minutes ago about sensor technology, also the ability to measure coordinate positioning has gotten so much better at a much more reasonable cost. But the materials in the frames are turning into, you're finding a lot of more alternative dampening materials, the polycarbonate composites, the automatic thermal coefficients of expansion correction. When you take a high-speed machine that's placing 80,000 parts an hour and you get it down to a 15 micron 3 sigma accuracy level, that requires some real science behind the design and deployment of that. And you're right. Going to a granite base depends on what you're doing. If you're going to be getting into a 5-6 micron level accuracy, you might have to go there. But at 15 microns, well, you can compensate for it.
It still amazes me, though, when you think about how small and how lightweight these parts are, that you have to develop a machine that is so many times the stability and the mass and everything to be able to place them at these speeds. It's just counterintuitive.
Right.
But I mean, like to your point, is that when you're placing parts that quickly, that accurately, that tiny, you can kind of understand it, but somehow it just still doesn't make sense to me. The layman person, like, oh my God, this thing's huge. It's thousands of kilograms, and my God, do we really need all that mass to be able to handle those parts? But it's what it requires.
You know, and it also means you have to map the surface of the board. The bigger the board, the more variability you've got in the board.
Absolutely,
so it means mapping the surface of the board. You've got the orthogonality of the board. You've got the warpage, the twist,
the solder paste location,
all
those different things.
Absolutely.
So, which pretty much segues into my next question, and that is about vision. I mean, should post-placement AOI be inside the box, or should it be a separate box?
That's a good question.
Depends on what kind of shop you're running. If you're a very high volume shop, first of all, you want to do it right the first time. And so there's a good argument that you may not need it anyway, right? But
you've got to verify that you've done it right.
Okay, so what do you do when it comes out of the oven? Or what do you do when it comes out of the machine?
You put it through an oven, which makes everything wobble.
Okay, so that's right. No, but you're right.
But when you put it into that reflow oven, though, you're then into money because you're actually.
That's right.
There's no going back.
There's no going back. Exactly.
But really, you're going to throw away the components to scrape off a board anyway. There's a lot of data that can be obtained. There's a lot of adjustment to your process that can be automated and fine-tuned and tuned in. But to be honest with you, I think that's going to stay outside of the machine for quite a while because nobody can afford to take the cycle time out.
Right. And then there's the old argument of having maybe too much functionality in the one box, and if something goes wrong, you're completely.
Even getting the industry to acknowledge the value of a pre-reflow AOI, I mean, still to this point, only about 20% of the industry utilizes a pre-reflow AOI. You know, there's definitely an advantage to being able to inspect the board so you can control the processes of screen printing and placement and so on before a reflow, but I think the market needs to acknowledge it. And if you go to the true spirit of Industry 4.0, having the technology to know exactly what's going on at the machine, as it's populating to indicate, due to whatever variable might be changing, adds value. And maybe for the folks that are building really high value products that cost hundreds of thousands of dollars, there's value to do it.
Yes.
But I think, compared to the overall market, I think it'll be a while before we get there from here, in general.
That's right. That's right. If you think about where all the defects are coming from, most of them are occurring before the pick and place machine.
That's true.
That's true. The further upstream you get it, the more money you save.
That's right.
That's
go ahead, sorry.
That's our policy with our AOI post-mounting, where you have an additional set of eyes on the process to terminate all the defects that you are creating during a production. To set up for a new product introduction, of course, it's definitely needed to have some extra eyes in the process before you go into oven. But also during the production process, you have to replenish trays. It can be exactly the same component, just with another type or the other serial number. It can be wrong. Vision will not detect it on the pick and place, but with AOI, with OCR recognition, you can define, this process will terminate these defects before it goes into oven. Right. So the step to closing as much as possible defects in the production line with a post AOI.
It's the last opportunity
it's definitely a benefit.
If you think about where most of the defects are occurring, over 70% of them are typically coming right off the screen printer.
That's right.
And so if you think about where automation is really necessary, how do you add a layer of an intelligence to that piece of it? You got a $2 million assembly system out here, and it requires somebody with a feel for the screen printer to make it all work right. That's ridiculous. Let's fix that, right? So that's been one of the big focuses of ASM is to take that guesswork out, add a layer of artificial intelligence with algorithms that have been able to have a true cause and effect relationship,
Right.
and automatically self-correct the line for optimal performance.
Right. But there's a number of different things can go wrong inside that printer, of course, and it's not all mechanically related to the stencil.
That's right.
It could be
Print
paste
pressure,
clog,
it could be all
sorts
kinds of,
things.
right?
So,
Release, all kinds of things.
So, I mean, current SPI systems that are talking to printers are really just looking at correcting offsets, maybe squeegee pressure, but not an awful lot more than that.
Oh, that's not true. Come over to the booth.
Okay.
We've got a full process engine that has 2 years of several industry experts' knowledge built into it.
Okay.
And actually, squeegee pressure, speed of the sweep, under stencil cleaning, offsets X and Y, the whole, paste height, paste content. You can tell by looking at it. What is the consistency of the paste? Is it right? Is it wrong? All of the above. Is my stencil wearing out even?
Right.
So it's quite interesting. Yeah,
Wow.
It's really gone to the next level.
Yeah, it sounds like it. I wasn't aware of that, Jeff. Now, most of you have opened, or are in the process of opening, technology centres, or competence centres, or where you pretty much help customers troubleshoot or run prototypes. How big a change is this for you? And do you need to have a firmer understanding of process-related issues and materials to be able to do this? Do you want to start with that, Richard, or you?
Yeah, well, we see we learn a lot from our own production line in our factory. We have our own production line where we're producing some of our own electronics, and customers can come to this environment, this production line, to see and learn from the whole process. So we do a lot of verification on our software, on new machine introductions. We do it first in our own factory as alpha testing, then going outside to beta testing. This technology and the knowledge that we're building up in our own factory, we make it available for our customers to learn from it and to share the information, how to optimize the whole program, the whole production process, from loading to unloading the complete line, and that's a big benefit for us.
Right. Shawn, your Cloud9 place in Chicago has been open about 10 months now, roughly. What are you seeing coming out of that?
What's excellent about it is that when they come, everybody here goes through a large effort to bring everything they have to Apex as best they can, and we actually have made it what we do here. We replicate there, so all year long everybody gets to see everything we have available, and it actually makes preparation for Apex so much better. So we actually set our roadmap of what we're going to do for next year. As soon as the show's over, we're already planning for what we're going to show next year based on what we know is coming in the pipeline, and so on. I'm one of the luckiest guys in the world in that there's so much expertise at our facility in Japan that a lot of times they can hand stuff to us and the knowledge and the expertise, and we can immediately incorporate what they take, and it's done in such a way that the process is perfected that is pretty much cookie cutting for us. And we can take what they've given us for knowledge. It doesn't mean that we don't have less expertise in our group, but it's a big advantage when you have a group of folks there that are real scientists of the print process and of components and equipment and building products, right? Panasonic makes a lot of products. They use our equipment to do it. So we leverage, just like Yamaha, we leverage that too, right? And so I think it allows us to be able to demonstrate those sciences and capabilities that we have. It allows customers to come and we become more of a consultant and more of a take what we learn, share it with them, and it allows them to accelerate their roadmap, their introduction of new capabilities. And so for us, it's been a great success. We're coming out with new equipment all the time, so actually fitting everything that we come out with into has become a big challenge. I thought I had this thing laid out for like the next 2 years, and now I'm already like, oh my God, I need more space. So that's one of the challenging things that comes from something like this. But no, it's excellent to work with the folks in Japan.
It's also a place that you set up lines, smart factory lines before, and get them working before you actually take them out for installation in the future.
And now we're getting in the material management aspect of things, so it's the whole MES integration and operating like a factory. From programming preparation, all that stuff, all the way through the back end.
So Jeff, you've got a few of these places, and you've got obviously one in Atlanta here. You've got one that just recently opened in Singapore.
That's right.
And of course your main one in Munich. I guess the beauty of the one in Munich is that it's next to
all the R&D,
your manufacturing and your R&D.
That's correct.
So you have that to draw on.
Yeah, I think there's actually two aspects of this. One is the deployment of existing technology and more applied technology, right? So helping customers through the more challenging aspects of whatever it is they're trying to build today. And then you've got the technology development side of that. So in Singapore, for example, ASM, of course, has over a 50% market share in the equipment that actually assembles the devices, assembles the components. So there's a tremendous amount of materials experience, there's a tremendous amount of component assembly technology experience, and how they all fit together. In addition to that, we have relationships with organizations like universities and colleges such as RIT. Now, this is more real technology development for photonics and advanced electronics development, etc. So if you think about it in terms of applied science and development of technology, you end up with two different sources, but they feed each other very nicely.
You have a benefit actually because you use a partner program pretty much with you.
Absolutely.
You learn quite a bit from your partners as well as the technology that's within Panasonic itself.
Yeah, it's actually quite amazing the level of collaboration, whether it be within our North American domain, but also at the factory itself. Some of the highest levels of experts and management are all collaborating all the time. And so, of course, we all would love to have everything from board fabrication and component fabrication through everything, but none of us can be suppliers of everything in the process. So partnership is critical. Like Jeff said, academia, right? Government, all those different things. I mean, if you look at what the Germans did with the whole Industry 4.0 initiative, they took everything from government to academia to industry and tied it all together and came up with, I guess, a vision, if you want to call it that,
that's right.
for all of us to kind of follow, and everybody's on board with that, because you know what? Back in 2000, 30% of the production was here, then Asia and Europe, but that all changed, and now you're trying to bring manufacturing back, and it means that, as Jeff said earlier, being able to have these machines be able to communicate to each other, to be able to operate it more efficiently, gain higher utilizations with less people that are less skilled, and be able to produce here.
With less people that are more skilled.
Right, and so it's going to really require we all collaborate.
Yes, that's right.
Well, whether it's a Yamaha machine with a Panasonic machine with an ASM machine, it doesn't really matter. I mean, at the end of the day, that's where we really need to strive to succeed.
Absolutely. It's far too complicated for any one company to do everything themselves.
Okay. Well, we're starting to run out of time, guys, but I'm going to finish on one question here, which is when can we expect to see measurable data of yield improvement coming off of these smart factory lines? You want to start?
Sorry?
When can we start to see measurable data of yield improvement coming off of these smart factory lines?
I think already today.
Yes.
You can definitely see in the production environments of today.
Right.
We have several customers who show where we can show the additional productivity compared to machines from 2, 5 or 10 years ago.
Yes.
It's already in process. It's already improving, and the flexibility of the line, it's bigger, so any type of production can be produced, and with the complete software suite around for preparation, all the processes where we were talking about the first question, it's material handling, it's the operator instructions, all these processes, they are already becoming at a higher level.
Right.
But cooperation with multiple vendor machine lines, it will increase even to a higher level.
Right. I think this is when it's going to start becoming compelling to manufacturers to want to make the move to having an intelligent, smart factory, where they can physically justify to their investors and the people who pay for these systems. Look, if we implement this strategy, we're going to have 20%, 30% improvement in our first pass yield.
That's right, and I agree with you, Richard. The day is here. It's there now. It's a matter of deploying it.
Right.
And if you think about a typical manufacturer, there's a great deal of reluctance to change what they're doing today.
Right.
But it's picking up momentum and it's gaining traction. So we're going to see it accelerate.
Well, here's an open invitation to all three of you. If you've got data that you would like to share with us, without giving company names, we'd be more than happy to publish that.
I'd be glad to do that.
I think that is what is going to propel this into the mainstream.
No question about it. No question about it.
Gentlemen, I want to thank you all very much for joining me today. It's been
Thank
a
you,
great
Trevor.
debate.
Appreciate it.
Thank you, Jeff. Thank you, Richard.
John, thank you.
Okay.
Trevor, thank you.
It's been
really
wonderful.
appreciate
Thank you
it.
very much. And thank you very much for joining us. That brings us to the end of our how much intelligence can you pack into a pick and place machine. We had quite a bit of intelligence on the panel this morning, so there you go. We'll be back at 12 o'clock with the Keith Bryant Show. Till now, thank you very much for joining us.
Good. Thanks.